All right. What do you remember about how to solve these absolute values? What do we need to do first? Say it again? Minus the 1. Yes. Sorry, my brain was not processing that correctly. I kept hearing it as multiply. But yes, so we need to subtract the 1 because our first goal is to isolate that absolute value. So we're going to start with minusing 1 to both sides. Ew, I'm a jerk, but that's okay. So it gives us 2 times the absolute value of x minus 6 equals 9. We're going to divide both sides by 2. We're going to wind up with a fraction, and that's okay. I'm going to bring this up over here because I wrote big. So now I have the absolute value of x minus 6 equals 9 over 2. And we can leave it as a fraction. You can put it as a decimal if you want to. 9 over 2 is 4.5. 4.5. Then what do? We can't add 6 yet. What do we need to do first? It's the absolute value, so we need to isolate and then split. So we need to split it into our 2 cases. I don't know why I put 2 P's in split. There we go. Totally on purpose. So it could be that my absolute value bars aren't doing anything, and x minus 6 really does equal 9/2. Or my absolute value bars might be doing stuff, and x minus 6 actually equals negative 9/2, or negative 4.5. Now what do? Do you remind me what was your idea a second ago? Add 6. That's going to give us that x equals, you're on the other one, on the positive one, 4.5 plus 6, 10.5. Now when we add 6 on this one, negative 4.5 plus 6 gives us Liam's 1.5. Right? Negative 4.5. Yeah. So our 2 solutions are 10.5 and 1.5. Or you could do 21 halves and 3 halves. Or 10.5 and 1.5. I don't care how we work it. You also should put those back in and check them. Make sure they are not extraneous. In this case, they do both work. Yeah. Questions on those? We're going an entirely different way in notes today. This is just a let's practice these because we went kind of fast and it's been a couple of days. Because we're going to keep working with our lines that we were talking about yesterday, those equations. Yesterday we switched everything into slope-intercept form. Today I'm going to give you a new form that we're going to play with. So you're going to need your notebooks because you're going to definitely need to write those down. We're going to work with a new form. It's called point-slope form. You may not have seen this form before. It is genuinely the easiest one to write an equation in because we use a point and a slope, point-slope, to write point-slope form. So the point slope form is y minus y1 is m times the quantity x minus x1. And just like we did in our slope formula that we talked about yesterday, the little baby 1 just means point 1. If I find a point that has x and y, we call that x1, y1. The x and the y without the little numbers are the x and the y that normally show up in like slope-intercept form. Y equals mx plus b. This is that y, and this is that x. Switch this to black. So this is the y there, and this is the x from slope-intercept form. So those x and y are going to stay x and y in our equation. M is still our slope. So to write point slope form, we use point and we use a slope. And we plug the pieces in. So you want to make sure you have down the y minus y1 equals m times the quantity x minus x1. So for example, we're going to do at the bottom down here, we have, what are we going to get with a slope of 2 and a point of 3, 4. So we're going to plug these pieces in. On this point, remember this is x, or x1, y1. So we're going to take our y from the formula minus the y from our point, 4. Equals our slope, 2 times the quantity x minus the x from the point, 3. Ooh, I gotta adjust those colors so they're a little bit bolder difference because they're a little dark. So this is our slope. There we go. Now I feel like we can see that color difference better, where those pieces came from. And that's the form. We don't have to massage it around to simplify it. We don't need to do anything like that. We can. We could absolutely distribute that 2 to get the parentheses gone. We could then scooch our 4 over to get it into slope-intercept form. And oh snap, we probably will later. But we're going to start with just building the pieces. We're just going to assemble it in point slope form with our point and our slope. And we're going to practice this a bunch of times. Okay, ready for me to change page? Sweet. Because we're going to practice it again. I gave us our point slope form at the top. It's way up here. Got our slope and our point. And if it helps, you can come through on these points and label them. x1, y1. Points are always x comma y. So we're going to build this together. A slope of 3 that goes through the point -1, 4. That is going to be the most commonly worded thing. So our y minus the y from our point, which is what? What's going here? 4. Equals our slope of 3 times the quantity x minus -1. X minus -1 becomes x plus 1. Watch out for the double negatives. Next one doesn't look like they gave us a point. Oh. It says we have a slope of 1/2 and has an x-intercept of 3. Is that enough information to be able to write this as an ordered pair? Think about an x-intercept. Has a y of 0. We know an x-intercept is somewhere on my x-axis. So if I don't have an x-intercept of 3, it's right here. So an x-intercept of 3 is the point 3, 0. So now we can write this as a point-slope form equation. I'm going to do our y minus the y value from my point, which is 0, equals our slope of 1/2 x minus 3. And I'm okay with us leaving it just like that. You don't have to simplify it. If you look at this and go, wait, y minus 0, that's just y, you can absolutely do that. But I'm also okay with us leaving it unsimplified. All right, one more like this. So we're going to have a slope of -1 and a y-intercept of 4. How can I write y-intercept of 4 as an ordered pair?
0.
0, 4. My x is 0. That's part of the definition of a y-intercept. So we're going to plug these pieces into our formula. Y minus 4 equals -1 times x minus 0. And again, I'm totally okay with us leaving it like this. We could also notice that x minus 0 is the same thing as x. And write it as -1x. Questions on these ones? Because next we're going to play with them just a little bit. We're going to smush it together with the slope formula we were looking at yesterday. And we're going to write an equation for the line that goes through these points. We have 2 lines here. And in fact, we're going to write 2 equations, maybe 3 equations that go through the line. Because we got mad skills like that. First thing we need to do is we need to use our slope formula from yesterday, which I did put up here. The difference in the y's over the difference in the x's. So for this first one that has the pair of points -6, 4, and 3, 1, we need to first things first find our slope. So what are we going to put on top? 1 minus 4. And then what goes on the bottom? 3 minus -6. Minus -6 becomes what? +6. So watch out for those double negatives. Questions on how we set any of that up? Okay, so what is 1 minus 4? -3. What is 3 plus 6? 9. Negative 3 over 9 simplifies down to be what? Negative 1/3. So our slope here is negative 1/3. When we are building our point slope form equation, I just need one point and a slope. I could also use that point and the slope. So we're going to build two equations in point slope form, and then this time we're also going to solve it down into slope intercept form. Because we're going to do it all. Because we're awesome skilled like that. So I've got my point slope form up there at the top, which I just zoomed in so you couldn't actually see the whole dang thing. Love that for me. So which point do you want to do first? The negative 6,4 or the 3,1? Negative 6,4. We'll do this one first. So to build this equation, we do y minus the y value from that point. So we're going to minus 4 equals our slope of negative 1/3 times x minus negative 6, which becomes x plus 6. Questions on our slope or on this first point slope form? Because we could also write this with that other point. It's totally fine and very nearly identical. I'm going to go darker purple in this one. So I'll do this one with this nearly black purple. So we're going to have y minus the y value from our point, minus 3, equals that same slope. Not 3, 1, sorry. I was supposed to use the right point information. With our slope of negative 1/3 times the quantity x minus 3. The exact mistake I made right there is the most common mistake we're going to have, where we accidentally flip-flop the x and the y. Then what we're going to do is I'm going to take one of these equations to put it in slope-intercept form. It genuinely does not matter which one, whichever one floats your boat. I'm just going to grab the bottom one because it's closer to the bottom, and I'm going to give us a little space so that I can write all my equations like kind of together. So if I take y minus 1 equals minus 1/3 x minus 3. How can I simplify this so that there's no parentheses and my y's by itself? I want to get this into slope-intercept form. We will need to plus the 1, but I can't really like add things into the parentheses on the right. So how can I get rid of those parentheses on the right? How? We can't add it on both sides because what's happening between the 1/3 and our parentheses? It's using multiplication. If I divide it, is my y going to be by itself? So we're just going to have to divide it again. So what can I do with that 1/3 to get the parentheses to leave? We can distribute it. We're going to take this 1/3 and we're going to multiply it out. Y minus 1 equals negative 1/3 x, just going to be what it is. And then minus 1/3 times minus 3 gives us what?
1.
Plus 1. So first thing we're going to do when we're taking point slope form into slope intercept form is distribute through your slope. Now I got to get my y by himself. And what are we going to do to get y by himself? Add 1. Add 1. So we're going to have y equals negative 1/3 x plus 2. So that is our slope-intercept form. Negative 1/3 x plus 2. So we found 3 different equations that go through both of these 2 points. We found 3 whole equations that do it. It's giving us a dividing line. So we're going to do the same thing for the other pair of points. Again, first things first is we need to find slope here. Before I do that, how are we feeling on this? Any questions on these 2? Because it's a whole lot of things. A whole lot of things. Okay, we're just kind of taking everybody and smashing them together. Let's find our slope here. What are we going to put on our slope? 2 minus 0 and 0 minus super close. Yeah, 0 minus negative 1, also known as 0 plus 1. So be super duper careful. Watch out for those negative signs. They become a little bit deadly. So 2 minus 0 is 2. 0 plus 1 is 1. 2 over 1, more commonly said as 2. So we have a slope of 2. So then we're going to assemble our point slope form. Do this one in the light purple, and I'll do this one in a dark purple, because they're the same thing, just different flavors. So we're going to do our y minus the y value from our point. Which one you want to do? Pick a y value. 0. So we'll do the dark one. Equals our slope of 2 times x. This x always stays as just an x. It's not going to have a number in that place. Minus the x value from our dark purple point, which is negative 1. So x minus negative 1, x plus 1. Our other point we have here, y minus our y value of our other point is 2 equals our slope of 2 times x minus 0. Take the x and y from the point. This one's using this point. So we've got our 2 different point slopes forms here. They make the same equation. They're the same line. They just look a little bit different. Questions on either of those 2? Because our last piece is that we are going to find our slope-intercept form. You can take either one of the equations. I do not care which one. The y minus 0, let's do the y minus 0. Y minus 0 equals 2 times x plus 1. And what are we going to do to get this into slope-intercept form? Distribute the 2. So we have y minus 0 equals 2x plus 2. Do I need to do anything with that 0? Nope. Because y minus 0 is the same exact thing as y. 2x plus 2. And we're into slope-intercept form. 2x plus 2. So that has smushed together all the things we've done in the past 2 days. We can write things in slope-intercept form. We can find slope from 2 points. We can write them then into point-slope form. And we're going to do a story problem. Our favorites. But this is the last one, okay? So story problem, same kind of vibe. Looking at the point slope form, we're going to use that in here. So we've got that the Tower of Pisa began tilting during its construction in 1178. That's a year. So we have the year 1178. And continued to move until the restoration efforts reduced the lean that stabilized the structure. Oh, and actually, we're not going to write that one down. The Tower of Pisa was leaning 5.4 meters in 1993. So in 1993, it was leaning 5.4 meters. Compared to a lean of just 1.4 meters in 1350. So in the year 1350, it was leaning 1.4 meters. So what we're going to do is write an equation for the lean of the Tower of Pisa. When we're looking at data, and we have years and meters as our 2 units, which one's x? Years. Units of time are always your x, if they are an option. So we have an x and a y, which means, oh look, I have an ordered pair here, and an ordered pair here. So even if we didn't have the whole paragraph and we were just given 2 points, we could figure this out. That's exactly what we did on the previous page. We are taking 2 points and we are writing an equation in terms of those 2 points. We are not going to get it to slope-intercept form because honestly our slope is going to be gross. But we're going to do the same thing we did there. We are going to start with finding our slope. Because I have 2 points, all I need is a slope, and I can get myself an equation. So what's going to go on the top of my slope equation? 5.4 minus 1.4. And what goes on the bottom? 19, exactly right. 1993 minus 1350. And that's going to give us our slope of how much it is changing. Remember the change in the lean per year. Change per year. So we're going to do that. We're going to wind up with a slope of 5.4 minus 1.4, 3, 1, 4. I'm good at thinking. Y'all, it's early. Is it 4? Write my original. Love that for me. I'm flying blind. Let's double check things. And then our years, what is the difference between 1993 and 1350? 643. So gross fraction, if you are anti-fraction and you would like it as a decimal, it's 0.006. We can also do it as the fraction, because again, we're not going to play around with it. We're just going to write it in point slope form and be done with it. So it genuinely does not matter which one we do. But what this tells me is that this is moving 0.06 meters per year. So then we pick one of our years, one of our pieces of information to write our equation about. We're going to have our y minus one of our years. I picked 1993 because I actually remember that year. I know that year. Except that's not the right number because I'm paying attention. I got excited because it was 1990s. I love the 90s. Y minus 5.4 because we used our y value equals our slope of, I'm going to use the decimal, 0.006 times x minus 1993. And what this will do is this will give us an equation where I can take a year, any year, I could put in 2021. I could put in 2023. I could put in 2050 and see what would happen in the future. And see if they hadn't stopped the tilting, how far would it have been tilted now? Because they did stabilize it in 1993, so it stopped leaning. So, barring earthquake, it should stay standing for a while. We're not going to move it around. We're just writing it in point slope form. We just got to find the pieces in the paragraph to work with, okay? So when in doubt, write down your pieces, figure out what your x is, figure out what your y is. And that's it for today. You guys have about 10 minutes until announcements start. Work on 2-3, same worksheet from yesterday. And that is, you're going to turn that in on Friday. Or Monday. If we need a little extra time, it's fine. Chapter test is the 22nd. Okay? You are going to need your computers tomorrow, so bring your Chromebooks tomorrow. Yes, dear. Oh, just staple them together. Totally fine with me. Totally fine. Yep, absolutely.